solved the question that was there.
Yes.
So first, let me start with this one. Okay.
Yes.
So, are you aware of the matrix and how to convert a matrix into the equilibrium?
No.
Echelon? Are you aware of this?
I have no idea.
Okay. So this is mainly related to converting a matrix into echelon form. Okay.
Mhm.
And then testing if fails the leaving zero, it can't be removed from the leading diagonal. So I will explain this. So first you need to convert the matrix into equivalent form. Okay. So how to do this? What is this first? Let's understand. I was bit more aware that it might be difficult for you to first understand the equivalent form. Then we will be going to the understanding of this theory. So I have prepared something for you.
Mhm.
So see,
Yes.
if you want to, so this is the theory. I will just first share the link with you so that I
Yes.
don't and Upwork. Okay. So this is the link that you can get from Euclidean form. So how to change a matrix into Euclidean form? Okay, so this is the funda, and this is the rule for it. So if you want to change in matrix to the Euclidean form, you have to follow these steps. Okay, the steps goes is that the first non-zero element, okay, the first non-zero element which you can get in each row is called a is called leading entry is one. Okay, so we have to first get the entry point where we are going to get the non-zero element. So first row, second row, third row, whatever row we are using, the first element of it should be non-zero. That should be our leading entry point. Okay. Then each leading entry is in a column to the right of the leading entry is the previous row. So any entry point that we are getting in a column to the right of the leading entry is in the previous row. Then we are going to compare the column of the right with the previous row, that is row above it. Okay, so that I will explain this. And rows with all zero elements, if any, are below rows having non-zero elements. So this is very technical term. I'm sure you will be getting confused with this. And what is reduced row equivalent form is when it satisfies the below condition that a matrix with zero equivalent form should be there and leading entry in which the row is only non-zero element. So this is the very alien language that they are using. So let's have an example to get it more clearance on it. Okay. So matrix is an echelon form. It's called a echelon matrix. Matrix A and matrix B are example of echelon matrix. Okay. Say for example 1, 2, 3, 4. Okay. This is so entry point will be this, right? And matrix E is an equivalent form and matrix B is the reduced equivalent form. So how? So how to transform a matrix into the equivalent form? Okay, so we will try to do that now. First of all, when you see equivalent form, how this is equivalent form, the last, this is 0, 0, 1, this is 0, 0, 0, 1. Are you see? The first non-zero element called as leading entry is 1. So this is 1. Are you getting? Then this is entry point is 1. Then each leading entry is in a column. Okay, each leading entry is in a column. Okay, to the right of the leading entry to the previous row. Okay, that is how can I explain? Okay, let's go step by step instead. Find the pivot, the first non-zero element entry in the first column of the matrix. Interchange the rows, moving to the pivot to the first row. Multiply each element in the pivot row into the reverse of the pivot, so the pivot is equals to 1, and add the multiples of the pivot row to each rows. So element of the to get the matrix row equivalent form, repeat the pivot, repeat the procedures of the step one along the previous pivot rows and continue until no more pivots to be processed. Get the matrix in the reduced form. This is what you need to do. So transform matrix into equivalent form as an example. Okay. So to illustrate the transformation process, let's transform the matrix A. This is the matrix A to a row equivalent form. This is an equivalent form, and to the reduced equivalent form. Okay. So this is reduced equilibrium form. Okay, so reduced Okay, double R they are referring is just a minute. So REF is a row echelon form and double REF is a echelon form. So see, this is exactly a simple matrix, right? And that this is the echelon form, row echelon form, and this is reduced echelon form. Okay, now I will show you step by step how this is achieved. Okay, to transform the matrix A, this A, into echelon forms, we implemented the following series of element row operation. So first we found the first non-zero element entry. Can you tell me which is the non-zero element entry in this?
In the first column, right, it's 21.
This one, right? So this is the non-zero entry point. That
Yes.
so that is the right thing. So we found the first non-zero entry in the first column of the matrix in row 2. That is first column and row 2, right? So we interchange the row 1 and row 2. So we interchange the row 1 and row 2. Are you able to see 0 1 2 is becoming 1 2 1 and 1 2 1 is becoming 0 1 2. So that is the step number 1. See,
Yes.
that first non-zero element, and then you have to first you have to find the known entry point, then interchange the rows moving to the first row, right? So that's
Yeah.
what we did it. We found the known entry point and we interchanged the rows. Okay, so this is first.
Yes.
Now, second is working with the matrix A1, working with this matrix A1, we multiplied each row with -2. Why -2? First question. Why here -2? Because we want to make the last three, this one to be 0, because this is already 0. Now we have to make this as well 0, right? To make this 0, which number you have to multiply here?
Oh, 2.
No, -2, because 2 minus 2 will be 0, right? So we have to do 2 minus 2. So you have to multiply this with -2 because this number is 2. So that's what it is doing. Working with A1, we multiplied the each element row by -2 and added the result to the row 3. So if you multiply with -2 plus 2 0, so it is 0.
Oh.
-2 into 2 is 4. 7 minus 4, 7 minus 4 is 3. And -2 is here, so 8 minus 2 will be 6. So 0 3 6. Here. Now next step is, this is A2. Now next step is working with the matrix A2. Still it is not Euclidean form. Are you able to see? There is no Euclidean form observed here. Okay, so what we will do, working with matrix A2, working with matrix A2, we multiplied each of the element of row 2, each of the element of row 2, this is row 2, okay, with -3. Why -3? Because this is 3. We have to make this 0. If you want to make this 0, you have to multiply this with -3. So 0 into 0 is 0 into -3 is 0. 0 into 1 into -3 is -3, and 3 minus 3 will be 0. Okay, and 3 into -3 into 2 is 6, so it is 6 minus 6, and 6 plus 6 is 0. Now you can see all becoming 0 when I multiply this with -3 and ending it here. Okay, now this is producing AREF. Notice AREF is in a row echelon form. Okay, if you notice this is into the row echelon form. Why? Because it meets the following requirement. The requirement is, number A, the first non-zero element is row 1. Are you able to see? This is 1.
Yes.
Right? The second quality is the first non-zero entry is the right of the first non-zero entry in the previous row. So the first non-zero entry, that is first non-zero entry, this is the first non-zero entry, okay, is to the right of the first non-zero entry into the previous row. So this is the previous row. Okay, if this is the entry point, this is the previous row. So that is also non-zero, right? So first non-zero entry is to the right of the first non-zero entry into the previous row. Okay, and third question, rows made up entirely of 0 are at the bottom of the matrix. Can you see? This is entirely 0 at the bottom of the matrix. So this becomes echelon form. Clear?
Yes. I have questions. So what do you use? Like, why do we need echelon form? Like, what do we use it for?
Yeah, the row echelon form that results from a series of elementary row is not necessarily unique. The different set of operations in the current. However, okay, so the use of it, I'm not sure of. Let me check. So it is some mathematically they must be using for the part of the theory. Okay, let's
Oh.
try to Google it. Where I'm not sure where echelon form of matrix is used. Let's try to. So row echelon commonly encounter in linear algebra when you will sometimes be asked to convert the matrix into the form, and row echelon form can help you to see.
So it's
So
not statistic. Ah.
it is used in linear algebra.
Oh, I thought it's statistic because when I Google it, it shows statistic.
No, no, no. It is just to get you. If you remember, right? We try to say, for example, let me try to use it a paint. Okay. So if you remember, we had like a 2x plus 1 is equals to 0,
Yes.
and what we can say, okay, not 2x plus y plus 1 is equals to 0, and x plus y plus 2 or minus 2 is equals to what we can do here, 0, right? Then what we were doing, we were trying to do the matrix of it, right? That is 2 1 1 1,
Mm-hmm.
right? And 1 minus 1 equals to 0, and we were solving this to get our x and y values, right? If you remember
Mm-hmm.
our last class, we tried to do this, right?
Mm-hmm.
So
Yeah.
same the situation, we are going to do it here. So what we need to do, you have to subtract this, multiply this, add this to get this value to be 0, and
Oh.
respectively our x and y was getting subtracted. So echelon form is nothing but the extension of the linear algebra.
Oh, I see. Oh, okay, I understand now.
Okay.
Yes.
Now so same thing that you are able to see that we did it here. Okay,
Mm-hmm.
same thing we are going to do using Python. That's it.
Oh, okay. Yes, I understand that. Yeah, I couldn't understand the concept, but I understand it now.
Okay, so see, now that what it is telling here, where is the file? See, in this exercise you will write a function of 4 by 4 matrix into a singular to determine the inverse exists or not. Okay, so the main idea of our particular job is to understand whether the particular, so what is special matrices? Okay, special matrices is nothing but we try to find whether there is an inverse of any matrix is available or not. So how to get that? Say for example, this is a matrix. Okay, A, B,
Mm-hmm.
C,
Mm-hmm.
D. So what is the inverse of this? Inverse of this is nothing. This is A,
Mm-hmm.
right? So inverse of this is what? A minus, right? And
Yes.
that is nothing but as per the formula 1 divided by this. Okay, and some values like D, A minus B and minus C, something like that, right? So
Mm-hmm.
this is the inverse of matrix A. That
Mm-hmm.
is nothing but you have to divide one. A inverse is nothing but it is just like this, 1 divided by 1. This is nothing but A inverse, right?
Yes.
Now it's the same concept. Okay, sometimes what happens is that when you are doing the inverse of the any matrix, the A, B, C, D, okay, and here is your A.
Mm-hmm.
Okay, whenever you are trying to do inverse of any matrix, you have to make sure that whenever you are doing this, okay, and this is D, this is A, this is minus B, and this is minus C. So
Oh.
while doing this inverse, we have to make sure this is not equals to 0,
Mm-hmm.
right? This should not be equals to 0.
Mm-hmm.
So that is nothing but our AD, that is this one AD,
Mm-hmm.
AD minus BC, if it is equals to 0, then that particular variable, then that particular matrices inverse is not possible. If AD, that is AD minus BC is 0, then that particular matrix is named as singular matrix, which means we cannot have inverse of that particular matrix at all.
Oh,
Okay.
yes.
That means, say for example, if I just give you the example, if it is 3 here, 2 here, if it is 3 here and 2 here, okay, so 3 2s are 6 minus 3 2s are 6, that is equals to 0. So inverse of this matrix is not possible.
Oh, okay, I see.
Or one more example, like it is 3 here, 4 here, 4 3s are 12, and 6 here, okay, then 4 3s are 12 minus 6 2s are 12 is equals to 0, which means inverse of this matrix is not, because whenever you do 1 by this, it is going to make this your value 0, which is going to make it a indefinite.
Oh.
Right, indefinite. So this means that this matrix can be named as singular matrix. Are you getting me?
Yes.
Okay, so this is the concept that is used here. In the exercise, you shall write a function of the matrix is singular or not. That is to determine whether the inverse exists or not. So first of all, our main objective is to find out whether the particular matrix is singular or not. Okay. So to find that, we have to first need to understand, you shall use the method of converting matrix to the Euclidean form first and testing if this phase 2 by leaving zeros, and that can be removed from the leading diagonal. Don't worry if you don't get, so remove this. Okay, this is just for the explanation. Now this is how the matrices is represented in Python. The first element is named as A00. This is row 0. Index starts with 0 in Python. So when I say A00, it is 0, first row and first column. This is first row and second column, first row and third column, first row and fourth column. This is second row and first column, second row and second column, like that. Okay. So you can access the element using individual as well. I will show you how. And if you want to access the entire row, you can get it as well. So first let me show you how. So say this is my matrix A. This is my matrix A. If I say A00, okay, you can see it is coming out with 2.0 because this is 2.0. Okay, if I just say A1, it is going to give me the entire row 1. If I just say A0, it is going to give me the first this entire thing 200.
Yes.
Are you getting? Now in this particular functions, this function is checking whether this particular the matrices is singular or not. So the idea behind checking this is to check whether this is singular or not. Okay, then here we are checking fixed rows 0, fixed row 1, fixed row 2, fixed row 3. So what is all this, right? So here our function will go through the matrices, replacing each row in order to turning into equivalent form. Okay, so our function will go through the matrix, replacing each row in order turning into the equivalent form. So this particular function will turn each row into the Euclidean form. Okay, if at any point it fails because it can't put a 1 in the leading diagonal, we will return the value true, otherwise we will return the false. If the particular diagonal we are not able to put any row 1, okay, so in diagonal, okay, in any diagonal, like this is known as diagonal. Okay, this is diagonal, like 1 2 3 4 5 6 7 8 9, then 1 5 9 are known as diagonal. Okay, so if we are not able to put a value 1 either here or over here or over here, or if it is fourth matrix over here, then we will consider it as a singular matrix and we will be able to mark that particular matrix as singular. So that is what it is telling.
Sorry,
If
can
any
I ask you again? So
yeah,
this is say like if this is say that if you cannot put 159 is equal 0, then is it singular?
no, we cannot make it 0. Either there should be an entry point as per the rule. There should be an entry point, right? So Euclidean form, there should be an entry point either here or here or here, right? So either here or here or here. So if we cannot find any entry point here, that is leading equals to 1, that means it is a singular one.
Oh.
So this is what it is like. If at any point, if it fails because it can't put a value 1 in the leading diagonal,
Oh, I see.
so we will return it as true, otherwise we will return as false. Okay, there is no need to edit this function. So this is checking, this is my converting into an array, whatever passing it, I'm just converting into array in a float form. This is trying fix row 0, fix row 1, fix row 2, and fix row 3. This is 0, this is 0, this is 1, this is 2, this is 3. Okay, so we try to first get this one, then try to get this one, try to get this one, and try to get this one. Okay, if you fail to do that, then obviously it is true or else false. Okay, so what is doing is a part of the fixed row 1. So what is fixed row 1? Okay, so let's start with fix 0, sorry, not fix row 1. Let's start with the first row, fix row 0. What they are doing as a part of the fix row 0 is, first it is going to check whether the first element is 0 or not. Okay, if it is 0, okay, if the first element is 0, okay, then we are going to take the entire first row and add it with the second row. That is, say I am having this matrices. Okay, so this is 1, 2, 3, or let's put it to 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Now, if this value is equals to 0, okay, then what I am going to do, if this is equals to 0, then I will check, I will convert this row, this is A0, right? This is A0. Right? Are you getting me? This is A0. This is A00. This is A00. Right? So I'm going to do A0, that is A0. This is A0 plus A1. So this one. So what will be A0 now? A0 will be changed to 0 plus 4 is 4. Right? 5 plus 1 is 6. 6 plus 2 is 8. And 7 plus 3 is 10. Right, so that is what it is doing. If A00 is 0, I have to do the summation of A0 and A1. Then again I will check, is it still 0? If it is still 0, then I will, again, as of now in our example it is not 0, but in this example, if it is this 0, and then I will try to get this as well as 0. And if I again check, is it still 0? And if I found out to be 0, then I will add the third row to the first row. That is what it is doing. Again, I will check whether it is still 0. Then yes, then I have to add the second row to the first row. Then I will again check whether it is still 0. If it is still 0, then I will add the third row to the first row. And if all this thing is coming out to be 0, then we will tell matrix is singular. Okay, and what is the idea to find the matrix to be singular? That it is not able to divide, right? So division will not be possible. So if it is singular, then it is going to stop here itself. If it is not singular, then we will get the first row converted into a covalent form, that is echelon form. Are you getting? So I'm repeating here, for row 0, all we require is the first element to be equal to 1, right? So for 0 row, all we require the first element to be equal to 1. This is what our requirement is, right? Now we will divide the row by A00. So we will need to divide the row by A00. Now say, this is, if you want to make, this is say 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. If you want to make this value 1, what you will do? Tell me. If you want to convert this value into 1, what you will do?
I will subtract it to the third row.
If you subtract it with the third row, it will make it 0. It will not make it 1.
Oh, I just subtracted to 4, but I'm not sure which row I need to subtract it to.
Yeah. So I'll just help you. If you want to make this 1, you have to divide all the elements with 5.
Oh, okay. But I thought
Then it
one example, you multiplied it to the third row.
correct. But here I want to make this as 1. So I can multiply all element, divide all element by 5. Then I will make this as 1. Then 6 by 5 will give me some value. 7 by 5 will give me some value. 8 by 5 will definitely give me some value, right? But my first element will be replaced with 1. Correct?
Yes.
Clear? So that's what it is. Now, if my first element it is itself 0, okay, when I try to divide anything by 0 or anything by 0, it will always be 0, right? So I will never be able to convert this value into 1. So what I need to do is I need to borrow the value either from this row to here or this row to here. And once I get some value here, I will divide the same number with the same number, right? So how did I find the 5? Because when I try to divide the same row, when I try to divide the same row, when I try to divide, I'm repeating 2 times, when I try to divide the same row with the first element of it, I will be getting the first value to be 1. So if it is 5, I need to divide by 5. If this is 6, I need to divide by 6. If it is 7, I need to divide by 7. If it is 8, I need to divide by 8 because I need to make it 1, right?
Yes.
Now, in our example, if it is 0, already a 0, a big 0, say this is already a big 0, okay? Say this is big 0, right? Now I need to borrow the value from the rows, this row, right? So first I will try to get the borrow it from here. So if I just try to borrow it from here, I need to add this. So 0 plus 1 will become 1, 2 plus 6 will become 8, 7 plus 6 will become 10, and 8 plus 4 will become 12. Now I will check, is it still 0? No. If it is not 0, then I can divide this value with all the other values. So 1 divided by 1 will give me 1, 8 divided by 1 will give me 8, 10 divided by 10, 1 will give me 10, and 12 by 20 will give me 12. Now I finally got this value as 1. Fortunately, it is coming out to be 1 itself, but say it is not 1 in case here in this example, say it is 7 here. Okay, then it is obviously 7 here, right? Then 7 divided, so I need to divide this then by my first row. This is 7, right? So 7 divided by 7 is going to give me 1, 8 divided by 7 some value, 10 divided by 7 some value, and 12 divided by some value. Are you getting me?
Yes, I understand. No? Yes.
Okay. So that is what we are doing it here. So first we have to find whether the first element is 0 or not. If it is 0, then we have to add the below row to the first row, okay? And if it is not 0, then we have to divide the same number which is present at the A00 value with all the other values here. Okay, so that is what we are going to do. You can see here that A00 will be divided by with the first element to make it singular matrix.
Yes.
Clear?
Yes.
So for row 0, all we require, the first element is equals to 1. So we will divide the row by the same value to make it 1. This will get in trouble if A00 is equals to 0. So we will first test for that if this is true or not. So we will add the lower rows to the first one before doing the division. And we will keep on repeating this test again and again till the time the first element is not non-zero. Okay, so first we will check this is 0. Yes, this is 0. Then we will add the first, second row to the first row. Then I will again check it is still 0. Then I will add the third row, second row, fourth row and all. So finally, if it is still 0, then it's a singular matrix. If it is not 0, then I have to divide the entire row with the same number. That is the first element to make my first element to be 0. So this is first fix row 0, right? Now for fixed row 1, add the subdiagonal element to 0. That is, which one is the subdiagonal element? This is subdiagonal element, right? So this is diagonal element, right? So this is diagonal element. And what is the subdiagonal element? This is the subdiagonal element of the row 1. This is row 1.
What do you define the subdiagonal?
Sorry.
How do you define the subdiagonal?
Yeah. So this is, say, this is row 0. This is done. Now we are working on this row, fix row 1. Now in this fix row 1, okay, this is diagonal, right? So any elements that is beside the diagonal are known as subdiagonal. So these are all the subdiagonals. These two are the subdiagonals.
Oh, so anything that besides the diagonal will be subdiagonal.
Yes.
I have a question. So the diagonal go through 7. So would 6 be subdiagonal?
Sorry?
Oh, so the diagonal go through 7.
Voice is breaking.
So would 6 be subdiagonal?
For row 3, 7 will be subdiagonal. You can see this is 9. So this will be the subdiagonal.
Ah, okay, I understand. Yes, I understand. Yes, I'm clear now.
Okay. Now that A10 will be subdiagonal, right? So this is subdiagonal. So if this is diagonal, okay, let me try to get the right picture. So this is going to give you the clear idea. So sorry for my bad drawing. So this is the diagonal elements. Okay. Now for row 1, there is no subdiagonal at all. For row 2, this is subdiagonal. For
Oh, I
row
have a
3,
question.
this is
So,
subdiagonal.
sorry, I have a
Row
question.
4, this is subdiagonal. Yes, go ahead.
So row 1, the first element that the diagonal go through is 0, 0. So the next bit is 0, 1 would be the subdiagonal, right?
No, we don't need to go right hand side. It is always the left hand side.
Oh, okay, I understand.
Okay.
Yes.
So that is what it is telling here. That is where it is. See, that is the row 0. Okay, this is done. So first we will set the subdiagonal elements to 0 to make it fix row 1. So A10, that is A10. So we have to make A10 to be 0. Next we want to make the diagonal element to be equals to 1. Next we have to make a diagonal element to be equals to 1. Then we will divide the row by A11. Okay. And again we need to test if this is 0. If so, we will add the lower row and repeat the setting of the subdiagonal elements to 0. So if you want to make any subdiagonal elements to 0, this is the formula. A1 equals to A1 minus A10 into A0. This will make your subdiagonal to be equal to 0. Okay?
Yes.
Then we will check, is my diagonal element equals to 0? If it is equals to 0, then I have to add the row from the below row and make again my subdiagonal to be 0. Again I will check, is this is equal to 0? If it is 0, then I have to add the third row and make my subdiagonal equal to 0. I will again check, if it is still 0, then I will consider it as my matrix to be singular. Else not, I will divide my entire row with my diagonal element. That's it.
Yes, I'm good.
Clear? Similar for the fixed row 2. No change. That's it. Okay. So here, this is the first function we should complete. So I have already completed for you. So this is, subdiagonal elements of row 2 to 0. So we are changing the subdiagonal elements of 2, 0 and 2, 1. So 2, 0 and 2, 1. So these are the, oh sorry, I just did a mistake here. Sorry, I agree with your point. So in this diagonal, this is the subdiagonal element of row 2. Okay, sorry for the confusion. So this is the subdiagonal element for the row 2. Okay, and these are the two subdiagonal elements for row 3, and these are the subdiagonals, means any column that is not part of the diagonal, and this is the subdiagonal element of the row 4. Sorry for the confusion. So this is the subdiagonal element of the row through. So this is diagonal and these all are considered to be subdiagonal. Clear? So that is what we are doing. So that is what we are going to do it here. So see. So see, this is row 2 0 and this is row 2 1. We are going to make it as a 0. So this is the formula to make your subdiagonal to 0. Then we will check, is it still 0? No, then we will add the below row and make it try to again do the same repetition. Okay. Okay, I think we have to, yeah, this is what you need to do. Correct. And then again I will keep on doing it till we got the 0. If still we are not getting any time 0, then we have to make it mark it as a single. So I think this is wrong. I need to make sure that both the lines are there. After reading it here, I need to make it this. Okay, it is already there. Sorry, it is already there. Correct. Okay, fine. So this will check whether the below line is 0 or not. Okay. And if it is still 0, then I will mark it as a singular. If it is not 0, I will divide with my diagonal value with the particular row. Similar for the fixed row 3, I will check 0, 3, 0, 3, 1 and 3, 2, make it diagonal to be 0. If it is 0, if it is still 0, then I will make it singular or I will just keep it as it is. Now let's try to test this. So you can see in this example, is this is singular? Yes, this is singular. Okay. Then in this example, is fixed row 0A? Then yes, fixed row 0A. Like this, it is going to keep on doing. Any doubts?
No, I'm good. I think I understand. Yeah, I think.
Very simple. Just you need to make it 1.
Yes, I was.
The diagonal elements should be 1.
Yeah, I was reading about the math and I couldn't understand at all, and I gave up. Oh, okay. Yes.
No problem. No problem. But now it is clear to you, right? What exactly we are trying to do.
Yes. Oh, okay. Yes, I understand.
You can just refer it. I will just give you 5 minutes of more time. Okay. Yes. If you want, I can just give you the.
Actually.